All right, guys, in this lesson, I would like to, we went over some of these examples in class, but here I'd like to go over a few more examples, okay, to help you guys to work on your homework. So I'm looking at your homework for week number 8, the last set, finding limit. And in this piece, our instruction is pretty specific. Okay, we just want to apply these two limits. Okay, we want to apply these two limits, x approaching 0. And these two limits we know is very important, plays very important roles as we find the derivative sign and cosine. And we got some algebraic skills to work with. Starting from the first one, actually, I can close this flashcards because we're going to be focusing on that. That way we have a bit more space. So we're going to put these two limits beneath us so we always have them coming along with us. And we're going to focus on some of these algebraic manipulations that you may be very familiar or need some refreshing. Okay, the first one, which we actually did it in class, but I'm going to do it again to show you. Okay, so we got limit. Find this limit as x approaching 0. Okay, and we get sine 5x divided by 3x. Okay. First of all, these two limits, we need to understand x, these three must be consistent. Okay, this x, that x must be consistent. This x, and that x must be consistent. For example, if I change this, right? If I change this to be omega, right? If I change this to be omega, then all of these need to be omega. They must be consistent. And what does that mean? Right? If omega is examples, if omega is going to be, say, this is a 5x, then this needs to be 5x as well. Okay, and 5x, so here, I can put x there. That will be the same. If this piece is 3x, and this needs to be 3x, and this can be x, because when 3x approaching 0, x approaching 0. Okay, when 5x approaching 0, x is approaching 0. That's what I meant, that you need to see these consistencies. So now we're going to demonstrate this by example. Okay, we're going to demonstrate this by example. So obviously we cannot, because we don't have 5x in the denominator. Well, if we don't have it, maybe we can make it by some algebraic manipulation, right? So we need a 5x. But how do we get a 5x? Well, we can do 5, right? Then 5x. But if we do that, we need to, if we divide by 5, we need to multiply by 5. You see? Basically, we have done 5 divided by 5. Principle number 1. Principle number 1. So when we do this, 5 times x, that will make the 5x. So we kind of switch place. Okay, we're still, anything times 1 stay the same. All right, we have to respect that property, but we switch place 5 with 3. So we have 5 here, 3 here. And that piece, that limit exists. We can apply that. I hope that makes sense. Okay, so now we look at two individual limits. So this limit exists, and that limit constant is stay the same. So we can find the limit separately, or we can bring the constant outside. We can bring the constant outside and just work on this limit. We have that property, don't we, on limit law? So this p is equals to 1, and that final answer is just 5/3. So you're going to see a lot of similar manipulations is needed just to apply these two properties. Okay, so I'm going to bring this with us so you just to remind you of that consistency. They all mean the same thing. Okay, now example number 2. Some of these manipulations, right? So for example, as x approaching 0, we have a sine x over sine of pi times x. Then what do we do? Right? We know that we have these identities, we have these limits, right? But we have to convert that to the form. So you're going to use some algebraic. We're going to use some algebraic manipulation, and the principle we use most of the time is principle number 1. Anything times 1 stay the same. So now what we need is this, right? We need an x. We're going to kind of separate it. 1 over, so here's sine pi, sine of pi over. This is 1, right? Just still the same. But I need an x here, right? If I divide an x, and then I need to multiply x. But over here, right, what do? I need a pi x here, because I can bring this x under, right? But I need a pi x here. You see, I need a pi x here. If I divide by a pi, then I need to have a pi over there. So anyway, when you reduce it, you should be going back where you started. Okay, so multiply pi divided by pi. And this x will go up, so you're going to go back exactly where it was. So if you reduce it, you should go back, right? So now I'm going to put the pi. I can put the pi over here. That's 1 over pi. Be careful that when you get to these steps, right, you have to know exactly what you're doing. But you can always check. You can always check and verify. So how do you check and verify? You bring all of these together, you simplify. You should go back exactly where you started. If that is not true, you have made a mistake somewhere. Okay, you have made a mistake somewhere. So you must check that these are the same. So do this, you always have scratch paper to work with you. So you can work with. Okay. After this is done, of course, we have checked it. Then the rest is that you look at, okay, this is the individual limit we are concerned with before we can apply the limit law. And this is an individual limit we can apply, right? We can use this principle, right? This limit. And 1 over pi is constant. So 1 over pi can be taken outside, right? Limit. So now, because each individual limit is, exists. So next, we can apply the limit law where you put the limits on the individuals. There. You see, we're applying limit law. Each individual limit exists, right? So now what do we get? we get 1 over pi is here. And this piece equals to 1. And that other piece, we have 1 over 1. So in the end, we have 1 over pi in our answer. Okay, so it's a bunch of algebraic manipulation. All right. So we haven't get to use the second one. We haven't get to use this piece. Okay, so let's see if we have a situation we can use that piece. Example number 3. Okay. So this time we have limits. Okay, so this time we use a different notation, theta approaching 0, right? Cosine theta minus 1, not minus 2, and sine theta. Sine theta. What are we going to do? Well, it looks like maybe this one applies, right? Maybe this piece applies. But this, to apply this piece, we need to divide by theta, don't we? We need to divide by theta, but we don't have it. We don't have it. So what do we do? Well, theta is approaching 0, but theta is not 0, right? Understand that, the definition of limit, right? All right, so we need the theta here. So what I'm going to do is I'm going to put it over here. Sine theta is moved here. They're still the same thing. They're still the same thing algebraically. And then what am I going to do? I need a theta here because this piece, I need a theta. I need a theta here. So I need a theta here. If I put a theta here, divided by theta, I would need a multiply by theta. You see, theta divided by theta is 1. Theta is not 0. It looks promising, isn't it? It's just really a whole bunch of algebraic manipulation. And one more manipulation is that if I bring the theta divided by theta, right? So have this one individual limit exist, and this one individual limit exist. And now we can apply limit law. So the limits we can take it individually on these two pieces. On these two pieces. And what are we getting? This piece will give us 0. And 0 times anything is 0, but you have to make sure you don't get 0 denominator. Okay, so it's 1 over 1. So in the end, the solution, the limit is 0. Okay, so by this time, I think you probably get the hang of it, right? You got the hang of it. I'm not going to take over all the questions, but at least you can see, and some of these questions require some factoring technique, Okay, so you need to do some factoring. And some of these questions require some more manipulation with trig function, all right? I hope by this time you guys should be ready to try out some of these other questions. So I'm going to leave you guys alone on trying some other maybe more difficult questions, but it requires some algebraic skill. But I don't want to just do it all for you. If you have any questions, please send them my way. I'll be happy to help. Thank you for watching. Until next time.